So after all the trials and tribulations of yesterday, we now have synthetic division, which makes this a whole lot easier. If you see Mr. Franklin and know who he is, pick on him because he hates synthetic division, and I love it. It is a cheat. It's sort of a cheat, and there's a reason why it works. But for right now, we're going to use it as a means to kind of get to the result quicker. So the first thing to know about synthetic division is that it only works when dividing by something in the form x minus r. So your x term has to have a coefficient of 1. Now we're going to have a way to get by that if it doesn't have a coefficient of 1, but it doesn't work if I'm dividing by something like x squared plus x. What I'd have to do is pull that apart and divide by the x and then divide by the x plus 1. And then for other polynomials it just won't work. So it is a little bit artificial, but you'd be surprised at the number of times we only just want to divide by a binomial, a linear binomial. So what I'd first do is I say, what are the coefficients of my polynomial? Coefficients are 2, -10, +9, and -15. I'm going to list those in order without the x terms. Then I'm going to draw a little half box, and I'm going to stick inside the opposite of this, or the number that I would plug in to make that 0, and that would be 3. So this one is going to be opposite sign. If you remember to do that, then you're set. I'm going to draw sort of what looks like an almost equal bar here, and I'm going to do an arrow down and carry the 2 down. And I'm going to do a little dotted line here, and you'll see why that is. This is the setup. That's entirely set up for what's going to happen. What happens next is going to happen so quickly you almost can blink and miss it. We're going to start an algorithm of multiply and then add, and we're going to repeat that. Multiply, 2 times 3. 2 times 3 is 6. I'm going to stick that here, and then add vertically. -10 plus 6 is -4. Multiply. -4 times 3 is -12, and then add -3. Multiply. -3 times -3 is -9, and then add -26. Or sorry, -24. I should add correctly. We're done. We can now just interpret the result that we have. This right here now represents a polynomial that's of 1 lesser degree than we started with. The 2 is our square term, 2x squared. The -4 is our linear term. The -3 is our constant term. And as you might imagine, the -24 is our remainder, minus 24 over x minus 3. You can get extremely quick at this, and it saves you a lot of time and probably a lot of mistakes too. Let's try this with number 2. I've got coefficients of 2, 9, 1, and -12. Inside this little pocket I'm going to put -4, draw an arrow down and carry the 2 down, and put a little pocket there. This vertical dotted line I use to separate the remainder out. So, same algorithm. We're going to do it a little faster now. Multiply, add, multiply, add, multiply, add. Remainder 0. That meant we could have factored the original polynomial, but we don't know a system or a means to factor that. That doesn't work with 2 and 2 grouping, and it doesn't work with 3 and 1. That would be a different factoring type that we haven't learned. But I can check to see if it divides x plus 4, and I can do that really quick. And I did. What you ended up with is x squared plus x minus 3. And that would be it. I just translate each of those into, once again, a polynomial of 1 lesser degree. Sometimes I like starting from the right to the left and say, that's the linear term, that's the constant term, and that's the quadratic term. And if I need to get bigger, I can. So, let's do one where, if I look at this, I'm going to write the coefficients in order 8, 2, and like before, I need to account for a missing term. It has 0 and -49. That's the first problem is taken care of. I've got these in order. I'm just going to squeeze that a little bit closer. But if you notice, now I'm dividing by something that does not have a coefficient of 1. It has a coefficient of 4. What I have to do is I have to replace that and say, well, 4x minus 7, I can write that as 4 times the quantity x minus 7/4. So what I'm really doing is I'm dividing by 7/4. Opposite sign. Carry that down. 8. 8 times 7/4 is 8 divided by 4 times 7. Then add, multiply, that'd be 28, and add, and multiply and add, and I get 49. That also gives me a remainder 0. So I have 8x squared plus 16x plus 28. Now, this took care of dividing by the x minus 7/4. I also factored a 4 out, so I need to divide this by 4, which is really easy to do because all of those coefficients are divisible by 4. 2x squared plus 4x plus 7. So in essence, what you really did is you took that, you divided it by 4, or sorry, you divided by x minus 7/4, and then you divided it by 4. And by doing that, you've effectively divided by 4x minus 7. So, what can we do with this? We can answer some questions like, is x minus 5 a factor of this? And I can do that quickly without doing long division. 2, 5, negative 68, and negative 35, and put a positive 5 into the pocket, and do this synthetic division. 2 times 5 is 10, plus 5 is 15, 5 times 15 is 75, minus 68 is 7, 7 times 5 is positive 35, and I get a remainder 0. And when you do these problems, read the directions for what it's asking. It's just asking a yes or no question. So the answer here is yes. And the reason why is remainder was 0. Now, number 5 says, is 7 a root of this? Well, if 7 is a root, then that means that when I plug 7 in, I would get that equal to 0. It also means that x minus 7 is a factor. Well, if x minus 7 is a factor, that would make 7 a root. If x minus 7 is a factor, then when I divide it, I would get a remainder 0. So let's try dividing by 7. Got 5, negative 13, negative 146, and negative 56. You don't need a lot of room to do this, which is really, really nice. Long division can get very, very long vertically. 7 times 5 is 35, plus 13 is 12. 7 times 12 is 84. And that would be negative 62. And 7 times negative 62 is huge. It's much, much, much larger than negative 56. You can write it down, but I would just kind of put a nope. Because again, 7 times negative 56 is going to be way, way too large to add to 56 and get a remainder 0. We can do a question, find k so that negative 6 is a root. Well, again, if negative 6 is a root, that means x plus 6 is a factor, which means that I would divide by negative 6 with coefficients of 1, 4, negative 5, and you guessed it, that's just going to be k. Find k so that it is a root. Well, what I want to have happen is I want to have a remainder of 0. So I'm going to start to build an equation using synthetic division. Negative 6 times 1, add, negative 6 times negative 2 is 12, 7, and then negative 42. And I need this to work out. And for that to work out, I would just say k minus 42 is equal to 0. So that means k is 42. We can do this with imaginary numbers. I can divide by, with coefficients of 1, 3, negative 2, and 3i, and divide by I, the opposite sign of this. Just remember your imaginaries. I'm going to bring down the 1. 1 times I is I. Add 3 plus I. Multiply. If I multiply the I times an I get a negative 1. And I multiply the I times a 3, I get 3i. Add. Negative 3 plus 3i. Multiply. I times 3i is negative 3i, or sorry, negative 3, and then I have minus 3i, and then add. I get negative 3. And the result of what we end up with, again, this is the coefficient of the x squared, plus this is the coefficient of the x. I'm just going to write it as 3 plus I x, plus, and this is the coefficient of the constant term, this is the constant term, negative 3 plus 3i. Then I have this is the remainder, minus 3 over x minus I. Look at the coefficients. We have a coefficient of 1, 3 plus I, negative 3 plus 3I, and then negative 3 in all those spots. And I'm just going to keep it like that. Don't FOIL it all out. I like having your coefficients be complex numbers. This is part of why we did that whole A plus BI thing back when we did this. Now you should be at practice seeing that. Lastly, it says find the polynomial q of x and the constant r. And then it says that this is true. Well, that just means quotient. And this just means remainder, which is just another way of saying divide. So if I want to divide by x minus 2I, so I set up my coefficients 2, 3, negative 4, and 20I, and I set up my little pocket. That's going to be a positive 2I. I start dividing. Multiply 4I, add 3 plus 4I. Multiply, that'd be 2I times 4I is 8, negative 8. Then 2I times 3 is 6I. Then add, negative 12 plus 6I. Then we multiply, 2I times 6I is negative 12. And then we add, then 2I times negative 12 is negative 24I. And then we add, negative 12 minus 4I. So quotient, q of x is 2x squared plus 3 plus 4I x plus negative 12 plus 6I. And my remainder is just negative 12 minus 4I. It's kind of the same as the previous problem, it's just a different way to ask it. And we're done.